problem, basically the task in this problem is to find the tension in each of the chords. Now, I know you're seeing A, B, and C, but these are referring to the tensions on each of those chords. Now, as I've said, this is quite fortunate for you since this problem basically has the illustration illustrated for you. Now, let's first go back sa katong first nato ang mga free body class because we are going to extract something out of it. Now, 'di ba, if you recall kanina in finding or making the free body diagram on the case where we focus our attention on the ring, ba ang ring na to nga naa diri kini akong gidrawingan diri this is where your three forces, namely T1, T2, and T3, are actually interacting. So naa sila tanan nga po, naa sila on that ring, nag-act ang all of the forces. Now, we will use the same idea on finding the point where the forces interact in solving for or in sketching the free body diagram for your problem C. Now, clearly in your problem C, I would ask again, how many free body diagram do we have to make for this one? So if you are thinking 2, then you are right. So for the first body, guess where is the first body? And do note that, as I've said earlier, na find the intersection where the forces are actually acting together. Now, if you try to think hard, you might come to the conclusion that this is the point of intersection of the three strings where the three forces, namely A, B, and C, are actually interacting. So that is my good, or that is a good reference point with which I will start to create my first free body diagram. So this is my, say, my body one, where I will be writing my free body diagram or illustrating my free body diagram. So, since that is the body where the three forces are interacting, the most convenient thing to do is to create an axis along that point. So, let's exploit that point there. Let's make an axis. So, that will be my y-axis. And over here will be my x-axis. Okay, I just have to write a longer one. Oh, okay, so that's my x-axis. So, as you can see here, this is quite similar with the previous problem and also simpler in the sense that unlike problem B where you actually have to rotate your axis kasi nga kailangan kining y-axis o x-axis naka-straight, your problem C is actually simpler in the sense that you don't have to do any rotation. Okay? Now, first question. In dealing with tension A, of course, if this is 30 degrees, automatically by the theorem in geometry, this is also your 30 degrees. Now, I'm just going to re-illustrate that again. If you have two parallel lines and then it is being cut by a transversal, so a parallel line cuts through that, transversal cuts through that parallel line. The theorem, I think you have to review your geometry or ask this from your geometry teacher, is these interior angles that you are seeing, alternate interior angles that you are seeing here, they are actually of the same measurement, theta and theta. Pareha na sila. So if this is 50, and this is also 50. And that is a geometric theorem. Alright? So after knowing that that should be 30, on the other hand, on the right hand side, you should be able to argue that that is also, this angle here is also 45 degrees by reasoning of the geometry of the problem. All right. So after that one, you have to determine again where is the direction of the tension force. A. So let's first deal with A. So clearly, di ba ang ato lang pangutan-on, okay? If we want to know the direction of the tension force, we ask this question. Where is it pulling with respect to the body? Now, the body that we are talking in this case is the interaction or the point 1 where the three strings are actually interacting. So the direction basically, where is it pulling relative to this body 1? This one here. So clearly that is very easy to visualize that actually your tension force is in this direction. It's going up and it is being pulled upward also because it's trying to support this weight here. On the other hand, if you try to look into this one for force B or tension B, it's actually being pulled also upward. So the direction of your arrowhead will be indicated upward there. All right. So if you remember again, since both of this tension A and B are not on the X or the Y axis alone, but they are existing sa imong quadrants, sa boundary ba sa imong quadrants, that is telling you that it has a component. So let's resolve the component here. This is the Bx, and this one, no, sorry, it should be B sub Y. That's your B sub Y, and over here is your B sub X, right? Now for the case of A, still, let's draw the components on A. From that going down, that is your Y component of vector A or tension A or force A, so A sub Y. And over here in the bottom is your A sub X. Okay, so I'm just going to have a dot lines over here. And that is the same A sub Y over there. I mean A sub X. And also for the case of B, so that's B sub X. And this is also B sub X, right? Now for C, so it's very easy to plot C since basically what we need for the direction of C is the fact that with respect to this body over here, well, the three forces are interacting. Your force C, where is it pulling? So basically, because of that mass, with respect to body 1 or intersection 1 nimo, your C is actually, oh, that should not be dotted lines. Your C is actually being pulled, or the string is actually pulling on that intersection over here towards the downward direction. So your C will just be down. So that's for the analysis of the forces on the first body. Now we are ready to actually sketch that into our Cartesian coordinate plane. I'm hoping I'm not making a very wait na Cartesian plane. So this is my x-axis and I define that as my y-axis. So let's start with a sub or tension A. So tension A will just be over there. And this is your 30 degrees. This is my A. And I'm just going to write the component. So you have to be very careful because this is what will be required during your test. You will not be solving yet problems, but you have to do this process so that whenever you solve problems, it will be very easy to follow through. This is your A sub X, and also in the bottom part, that is also your A sub X. Now for your vector B, it's directed over there, and it should be 45 degrees. The arrow is upward, and let's find the broken lines. Did I use the smaller one? I guess I did use the smaller one. Okay, so this one here, which lies, the component which lies along the y-axis is undoubtedly, that's your B sub Y, since this is your vector B. And the one that lies along your x-axis, okay, it's Huey. X-axis over there is your B sub X. That's your B sub X. In the same manner, this is also your B sub X. But I do recommend, class, for ease, that you just write one of this, either diri lang ka magsulat or diri, or you take the top or the bottom. Either way works. And you will see the reasoning later why I advocated or suggested that it's better to focus only on one. So we still have what? napaisa ka force that we are unable to account, and that is C. So the force on tension C will just be directed downward. So that is your free body diagram for 1. Again, where is 1? The intersection of the 3 strings. Now we still have another free body diagram for object 2, or interaction, or maybe the point 2. This is your point 2, where actually the mass of the hanging whatever object this is. So simply, since that is hanging and it has a mass, the first thing that should come up in your mind is the fact that it has this force. Ang sa ganina, the force that is always towards the center of the earth. Therefore, in your free body diagram, it will just be a straight line. That is your weight. And another thing is, you try to look into the illustration again. There is still, or this weight is connected with a string, right? So this string here over here, this is the string that I'm talking about. So since it's still connected with that with respect to body 2, this one over here, it must be that the case where some force still exists on the y-axis upward. I'm talking about this line over here. So that is still C because the same chord ang nag-connect ana niya. But let's ask again of what should be the direction. Take note on the body 1 or point 1, the C is directed downward. Now in this case, let's try to check whether C is downward. How do we get the direction? Baliktad dere. We deal with tension, we want to get the direction, we ask this question. Where is it pulling? Sa Bisaya pa, adto nga body or adto nga point asa man sa gabira pa ingon. So I'm hoping that is clear in our vernacular language. So clearly, from this body, this tension C is actually trying to pull that object upward, right? Because of the weight is going down, the string is actually trying to pull that upward. So the direction of C in the case of the second body is upward. So for your second body, you illustrate it in this manner. Of course, you start with the Cartesian coordinate plane, and we just define where is the x and y. So do not forget to define where is your x and y. Just like this is my x and this is my y. Now, the first force is the force due to the mass, or simply the weight of that object, and that is downward. And then the other force is the force due to string C, which is trying to pull it upward with respect to body 2. Therefore, your C in this case will be situated there. If you notice, your C here is moving down, your C here is moving up, and that's okay. Because basically what we are talking here is, whenever we try to get the direction of the tension, you just ask, which direction is it pulling? Is it pulling? So that's why with respect to different bodies or points, in this case for 1 and 2, they have different direction of the tension C. All right? So that's it for this video. I'm just going to write over here FBD4. Okay.